Hello my friends and welcome back to the You Can Do TV channel. Amid glowing furnaces and the deep rhythm of steel, Tekki Zelazari carries on a tradition more than 180 years in the making. In the heart of Central Europe, nestled among the Beskid Mountains, this historic steelworks stands as a testament to resilience, craftsmanship, and industrial strength. Since its founding in 1839, the plant has played a vital role in Czech metallurgy, where raw materials become the backbone of modern civilization. The journey begins in the blast furnace, where iron ore, coke, and limestone are smelted at over 1,500 degrees Celsius. In this intense environment, iron ore is reduced to molten pig iron, which is then transferred to the basic oxygen converter. Here, pure oxygen is blown into the molten metal, removing impurities and lowering the carbon content to produce high-grade steel. Next, the steel moves to continuous casting machines, where it is solidified into billets, semi-finished products ready for shaping. Reheated and passed through powerful rolling mills, these billets become beams, rails, rods, and bars tailored for construction, energy, transport, and other key sectors. Precision is paramount. Every stage is monitored by advanced automated systems, ensuring tight dimensional tolerances and consistent metallurgical quality. Sustainability is central to the process. Tekki Zelazari uses modern dust filters, recycling systems, and heat recovery technologies to reduce environmental impact and conserve energy, helping shape a greener future for steel production. Forged by tradition, refined through innovation, this is steelmaking at Tekki Zelazari, where the fire endures and the sound of steel never stops. From molten metal to solid strength, cast iron has shaped industry for centuries, silent, heavy, and built to last. But how is this timeless material born in modern foundries? The cast iron production process begins with the careful selection of raw materials: pig iron, steel scrap, and foundry returns. These materials are loaded into a cupola furnace, or an induction melting furnace, where they are heated to temperatures around 1,400 to 1,500 degrees Celsius. Once the metal is fully molten, precise alloying elements such as silicon, manganese, and carbon are added to adjust the chemical composition, giving the cast iron its required mechanical properties and structure. The molten iron is then transported in ladles and poured into sand or metal molds, shaped according to the final part's design. These molds are usually made using a resin-bonded or green sand system, which allows for intricate geometry and high surface finish. As the iron cools and solidifies inside the mold, it takes on its final form. The cooling rate is tightly controlled to influence the microstructure, especially the formation of graphite in gray cast iron, or the nodular graphite in ductile iron. Once solidified, the casting is removed from the mold and allowed to cool to ambient temperature. It then undergoes shot blasting to remove sand and scale, followed by machining to achieve final dimensional accuracy. The finished cast iron component is now ready for use in machinery, pipes, engines, or structural supports, proof of a process where metallurgy meets mastery. At the Inakv metallurgical site, the process of slag disposal unfolds with intense heat and precision. Molten blast furnace slag is poured from a slag ladle into the slag dump, forming dramatic cascades of glowing material. This byproduct, separated from molten iron during smelting, is directed to a designated disposal area where it cools and solidifies. The slag is later processed or stored, depending on its composition and potential for reuse. The operation requires careful coordination and specialized equipment to handle the extreme temperatures, ensuring safety and efficiency during every slag pour. At Tironi Foundry, aluminum casting is supported by a fully integrated production chain. From 3D product engineering and process simulation to casting, machining, and painting, every stage is optimized for precision and efficiency. Rigorous quality control and full product traceability ensure reliability. Tironi also manages supplier sourcing, quality audits, logistics, and final assembly. With expertise in metalworking and modern engineering tools, the Foundry delivers high-quality aluminum components tailored to customer specifications across various industries. At ILSAM, hot steel forging is carried out with strict quality control at every stage. From raw material selection to dimensional and structural inspections, the company manufactures forged parts for tractors, construction machinery, industrial vehicles, agricultural equipment, engines, motorcycles, hydraulic cylinders, and railway systems. Forging is performed using double-effect hammers up to 3,000 tons and mechanical or screw presses up to 2,000 tons. ILSAM manages both mold design and production, combining advanced CAD/CAM technologies with expert craftsmanship. Mechanical machining and heat treatments are applied to the forged components, ensuring precision, strength, and reliability for demanding industrial applications. This is the story of a fully robotic forging line, where metal rollers are transformed into precision truck parts without a single human touch. It begins with advanced bin picking. A 3D scanner identifies steel blanks up to 20 kilograms, guiding a robot arm to lift and position them on a conveyor. Induction heaters bring the blanks to forging temperature before a 4,000-ton press forms them into shape. A 500-ton trimming press removes excess material. 6 synchronized robots handle every stage: loading, forging, trimming, reducing noise, eliminating manual labor, and boosting consistency. A seamless process built for efficiency, precision, and the demands of European heavy industry. At Dysttol, forging begins by heating the raw material to 1150 to 1250 degrees Celsius before placing it under the hammer. Forging is one of humanity's oldest crafts and remains the core tradition of the company. While the anvil and hand hammer have been replaced, the principle stays the same. Parts weighing from 10 to 2,500 kilograms are forged using steam hammers, weighing 300 to 6,000 kilograms, and hydraulic presses. Small pieces are still manually positioned, using tongs and levers, requiring teamwork and skill. Each forged piece is stamped with a commission number to ensure identity and traceability. Larger parts are handled by electro-hydraulic manipulators. The WIM-35H is a semi-automatic, servo-controlled CNC lathe coiler designed for the hot coiling of cylindrical springs directly from bar stock. Engineered for precision and durability, this machine handles the production of springs with round cylindrical straight cuts or tapered ends, ensuring high-quality results for demanding applications. Ideal for manufacturing large-diameter hot-coiled springs, the WIM-35H operates by feeding preheated bars into a servo-driven rotating coiling head, forming the spring geometry with consistent accuracy. The CNC control system enables real-time adjustment of coiling parameters such as pitch, diameter, and bar feed, while programmable settings support repeatability and quick changeovers between different spring designs. The machine is equipped with a heavy-duty frame, integrated servo motors for accurate motion control, and a user-friendly interface for easy operation. It also includes features like hydraulic clamping, automatic length measurement, and optional end tapering tools. Designed for reliability in tough industrial environments such as railway, automotive, and heavy equipment sectors, the WIM-35H offers an efficient solution for producing high-performance hot wound springs with minimal manual intervention and excellent dimensional control. The KSS-800 is a robust carbide circular sawing machine with an inclined bed, engineered specifically for cutting forged axles with high precision and efficiency. The process starts with laser detection of the reference edge, ensuring exact positioning of each axle. The system then feeds the material for the front cut, removes the resulting scrap, and automatically tilts it aside. Afterward, the axle is transported to the tail cutting station, where it is securely clamped for the final cut. Following the tail cut, scrap is once again removed and tilted to a discharge area. The finished axle, now trimmed to exact specifications, is ready for downstream processing. With full automation, from in-feed and cutting to scrap handling, the KSS-800 ensures accurate, clean cuts, minimal material waste, and high throughput. It is ideally suited for heavy-duty production lines in the railway and commercial vehicle industries. The Doosan Puma SMX5100L is a high-performance, multi-axis mill-turn CNC machine designed for complex, high-precision machining. Featuring 9 axes, dual spindles, a B-axis milling head, and a lower turret, it offers exceptional multitasking capabilities for faster machining and reduced setup times. Its orthogonal structure maximizes workspace, while the 12-station servo turret ensures powerful and reliable cutting. Precision is maintained through 0.0001 degree B- and C-axis control, smart thermal compensation, and an advanced cooling system. A front-mounted tool magazine and intuitive ATC panel simplify tool changes, supported by a user-friendly swiveling operation panel with adjustable height. The Heller HF3500 Machining Center demonstrates outstanding precision and surface quality in mold and die production. Equipped with the powerful District of Columbia 63i spindle and PRO equipment package, it is optimized for high-performance machining of tool steel 1.2343 x38 CR MOV 5:1. Machining a part begins with E63mm face milling for external roughing, followed by E40mm high feed milling for internal roughing. U12mm end mills handle side pocket roughing, while U20mm tools are used for circular pocket milling. Remaining material is cleared with U10mm end mills, which also perform external finishing. For fine internal surface finishing, A EU 5mm ball nose cutter is employed, ensuring exceptional accuracy and surface integrity. Kennametal's Maxi-Met carbide end mills are engineered for high-speed aluminum machining, delivering exceptional metal removal rates and superior surface finishes. Ideal for alloys like Planaloo 5083, these tools are designed to reduce cycle times and boost productivity. Models such as ABDEO800A3AS and ABDE1600A3AS offer optimized geometries and advanced coatings to handle demanding applications with precision and efficiency, making them perfect for aerospace, automotive, and general machining industries. This copper cable recycling separation table demonstrates fast and efficient separation of plastic and copper fractions from granulated cable. As the material feeds onto the vibrating table, differences in density allow clean copper to separate quickly from the lighter plastic insulation. The standalone unit operates with high precision and speed, producing a high-purity copper output ideal for resale or reuse. It's a compact, efficient solution for maximizing recovery value in cable recycling operations. At WEC Group, the Soraloo 8000 floor-type milling and boring machine plays a key role in machining large, complex components with precision. Equipped with a robot tool changer and a 130-tool magazine, it offers high flexibility and efficiency. The stepless universal head, along with an automatic head-changing system, allows versatile operations including horizontal boring with a U 230mm, 480mm long head. A massive rotary traveling table, 3,500 by 3,000 millimeters, supports up to 60 tons. Additional features include external head cooling and a traveling operator platform, ensuring both accuracy and operator convenience in heavy machining environments. Bimitex Soraloo showcases the company's complete ecosystem of high-end machining solutions, engineered for maximum flexibility, precision, and durability. Specialized in producing multifunctional milling and boring centers, Bimitex Soraloo serves sectors such as general engineering, mold and die, energy, transportation, and heavy industry, offering machines capable of high-performance metal cutting under the most demanding conditions. The product portfolio begins with the T-Series, compact bed-type milling and boring centers designed with reinforced cast iron beds and cross slides, tailored for medium-sized workpieces. These machines offer high precision, rigidity, and thermal stability, featuring linear guideways and powerful motor spindles. Next is the S-Series, consisting of fixed-table machines built for high stock removal, ideal for deep cavity and heavy-duty milling applications. For operations requiring greater versatility, the F-Series stands out with a traveling column configuration. These machines are designed for pendulum machining, allowing continuous part processing by alternating between dual setups. The FMT variant goes even further by integrating milling, turning, and grinding on a single platform. It includes features like rotary tables for heavy parts, automatic head-changing systems, and thermal compensation for long-run dimensional stability. The PM and PMG series consist of portal and gantry-type milling centers, providing large-scale solutions for oversized components in the aerospace and energy industries. These portal machines offer high stiffness, hydrostatic axes, and heavy-duty spindle heads capable of working across large work surfaces with excellent dynamic behavior. The structure minimizes vibrations and increases finish quality, even during extreme cutting forces. The VTC series, vertical turning and milling centers, offer powerful multitasking capabilities with hydrostatic rotary tables and optional live tooling. These machines excel in processing large cylindrical workpieces with high torque requirements, making them ideal for industries like rail and wind power. Each machine in the Soraloo lineup supports advanced tooling solutions, including high-precision, orthogonal, and universal milling heads. These heads feature automatic indexing in 0.001 degrees increments and are driven by powerful torque motors and Hearth couplings for repeatable and rigid positioning. All heads are managed by automatic tool and head changers, with magazines holding up to 200 tools. Tool change operations are controlled by high-speed servo arms, minimizing idle time between operations. Bimitex Soraloo integrates advanced digital systems, including DAS+, Dynamic Active Stabilizer, which actively reduces chatter and vibration during machining. This ensures better surface finishes, longer tool life, and reduced scrap rates. CNC control is provided by Siemens or Heidenhain platforms, offering intuitive operation and seamless integration with digital manufacturing systems. Beyond machine manufacturing, Bimitex Soraloo maintains a full-service facility in Limburg, Germany. This includes a technology and demonstration center, spare parts warehouse, logistics hub, training academy, and a live milling head assembly and repair workshop. Customers can run machining trials in the test center, receive training, and consult with application engineers to tailor processes to their exact specifications. With over 1,000 machines delivered worldwide and an ongoing commitment to innovation, Bimitex Soraloo continues to redefine machining efficiency and reliability. From initial consultation through to long-term service, the company offers a complete, German-engineered solution for the most ambitious manufacturing challenges. In the peaceful, wood-scented workshop of Frederick, Chile, the centuries-old craft of cooperage, barrel making, continues with dedication, tradition, and remarkable precision. As a master tonnelier or cooper, Frederick carries on a legacy where hand tools, open flame, and oak staves come together to shape more than just barrels. They shape the character and soul of fine wines and aged spirits. The process begins with the selection of high-quality oak, most commonly from the forests of France. These oak logs are split and then left to age naturally outdoors for 2 to 3 years. This vital seasoning process reduces the wood's natural acidity and bitterness, while allowing the tannins to mellow. The seasoned oak is then crafted into long, curved pieces called staves. Each stave is jointed and planed with meticulous care, ensuring that all pieces will fit together tightly without adhesives or fasteners. Once the staves are prepared, they are raised into a circular frame and held temporarily with metal hoops. At this stage, the barrel's familiar shape begins to emerge, though the wood is still rigid. To curve the staves inward and set the final form, the barrel is placed over an open flame, This crucial step, known as bending or chauffe, uses heat and humidity to make the wood pliable. While over the fire, the inside of the barrel is slowly toasted. The toasting process is adjusted in time and intensity depending on the winemaker's desired influence. Light, medium, or heavy toast will impart different aromatic profiles, such as vanilla, spice, or smoky notes. After toasting and shaping, the cooper fits the barrel heads, circular oak ends, into grooves and seals them securely. Final hoops are hammered into place, locking the structure. Every joint is tested for tightness, and the barrel is filled with water to check for leaks. Once verified, the surface is carefully sanded and often branded with the cooperage's mark. Using hand tools such as crowsers, adzes, and draw knives, Frederick ensures each barrel is crafted with the same attention and respect as those made generations ago. His workshop blends human touch with natural material, creating barrels that are both functional and artistic. Each barrel is a silent collaborator in the aging process, infusing flavor, structure, and elegance into its contents, a true testament to the enduring art of cooperage. The Byler GR-MNC Servo Multi-Slide Machine is a high-performance servo-controlled system designed for producing stamped, formed, and wire components in small to medium batch sizes. With stroke rates up to 250 cycles per minute and full compatibility with Byler's LEANTOOL and L250 systems, it enables fast setup and high reproducibility. It supports complex linear processes with up to 3 bending modules and 2 servo presses. Offering tool compatibility with previous GRM models, it delivers up to 300% increased output and reduces setup times by up to 90%. Suitable for material up to 4 mm thick and 90 mm wide, it ensures precision, speed, and flexibility in forming applications. The AFE 2D6 Ultra CNC Wire Bender by AIM Inc. is currently the world's fastest automatic wire bending machine. Engineered for industrial applications, it straightens, measures, bends, cuts, and forms metal wires at incredible speeds with unmatched precision. Designed with servo-controlled modules for feeding and bending, it supports clockwise and counterclockwise motions, dual folding, and complex shapes in one operation. The machine allows on-the-fly programming, real-time simulation, and offline code uploads. Equipped with a hydraulic cutter for high-tension wires, touchscreen interface, and seamless metric/imperial switching, it delivers superior productivity and minimal setup time. The Salvagnini P2 panel bender redefines flexibility in sheet metal processing, breaking traditional bending limits with advanced automation. The Salvagnini P2 panel bender is a highly advanced sheet metal processing system that integrates automation, precision, and efficiency. Engineered with adaptive technologies, it automatically adjusts blank holders and bending parameters in real time, eliminating manual setups and reducing cycle times. Capable of handling sheet thicknesses from 0.4 mm to 3.2 mm, it accommodates a wide range of materials including stainless steel, aluminum, and mild steel. This aligns with modern market demands for efficiency and sustainability, offering unmatched versatility and performance in compact, intelligent bending operations. The P2 truly brings next-generation technology to modern fabrication floors. Creating the AK-47's iconic 30-round steel magazine is a process grounded in mechanical efficiency, battlefield logic, and sheer practicality. Like the rifle it feeds, the magazine is engineered for simplicity, mass production, and long-term survival under extreme conditions, from frozen tundras to sand-choked deserts. The process starts with high-strength, cold-rolled sheet steel. 2 flat blanks are die-stamped into symmetrical halves using hydraulic presses. These dies impart not only the distinctive curved profile of the magazine, but also the strengthening ribs, which resist crushing forces. This curvature follows the natural taper of the 7.62x 39 mm round, preventing feeding jams and enabling reliable cycling even in full auto fire. The front and rear spines are formed and welded, typically through spot or resistance welding methods, ensuring a durable, rigid structure. The feed lips, essential for proper cartridge alignment, are stamped into the upper edges and precisely formed to tight tolerances. The magazine locking lug and front catch tab are also welded or riveted onto the body to ensure secure engagement with the rifle's magazine release. A stamped or molded follower rides smoothly atop the spring, with chamfered surfaces to reduce binding. The base assembly includes a floor plate retainer and a stamped floor plate, slid into place and locked, allowing for field disassembly and cleaning. Before the magazine is cleared for service, it undergoes surface finishing. Traditionally, this includes phosphate treatment, followed by enamel or lacquer coating to prevent rust and corrosion. In later years, polymer-coated or composite body variants have also been introduced, offering lighter weight while maintaining the same feeding reliability. Every finished unit is test-fitted for function. The result is a component renowned for reliability, capable of surviving dents, mud, sand, and neglect. Built to be thrown, dropped, or buried and still work, the Alaska 47 magazine is a masterpiece of utilitarian design, one that continues to serve in conflicts worldwide, decades after its inception. The Iowa Precision Colatch is a high-performance HVAC duct collar attaching machine engineered for precision and versatility. It forms beads for collaring, expands boots or takeoffs, and grooves both the collar and the boot for a secure fit. Its stable 3-legged design ensures accurate leveling. It handles duct diameters ranging from 4 to 20 inches, making it ideal for fabricating furnace fittings. The copper tube making machine is designed for precise end forming of copper and aluminum tubes, widely used in air conditioning, refrigeration, and cold storage industries. It performs operations such as expanding, flaring, swagging, reducing, necking, or sealing tube ends. Depending on production requirements, machines are available in 1 to multi-station configurations. This equipment improves automation efficiency, reduces labor, and processes up to 4 tubes simultaneously under unified control. With compact design and automated operation from loading to forming, it significantly lowers time and cost while enhancing productivity in copper tube manufacturing plants. The RMTA Fab 472 angle roll delivers exceptional performance in hard-way beam bending, one of the toughest challenges in structural forming. Built with a rugged, precision-welded steel frame, the machine ensures strength, stability, and long-term durability. With advanced pulling apparatus integration, it handles I-beams, H-beams, and other structural profiles with consistent precision, even in hard-way configurations. RMT's induction-hardened, heat-treated internal components and hydraulic-powered rolls guarantee repeatable accuracy with minimal correction. Designed by world-class engineers, the AFAB 472 offers unmatched control and adjustability, significantly reducing material waste and rework time. Capable of spiral pipe rolling and profile forming, the angle roll operates efficiently with smart controls and tight radius capability. It comes equipped with lateral material guides, touchscreen interface, and digital feedback for real-time bending position monitoring. Trusted for demanding applications, it's the ultimate solution for heavy structural steel forming. Steel wheels for heavy-duty trucks are built to endure extreme loads, road conditions, and long operating cycles. Their production involves a series of robust forming and precision machining steps that transform raw steel into high-strength, reliable components essential for commercial transport. The process begins with rolled steel coils, which are uncoiled and cut into circular blanks, known as slugs. These blanks are to the optimal forming temperature. Each blank is placed into a hydraulic press where it is deep drawn into a bowl-like shape. This forms the wheel's initial contour. Next, the formed discs undergo trimming and piercing operations to create the center bore and bolt hole pattern. These features are critical for mounting the wheel onto the hub and must adhere to strict dimensional tolerances. Using CNC machining centers, the holes are precisely drilled and chamfered, ensuring exact alignment and fitment. Following this, the rim section is manufactured separately. A flat steel strip is bent and welded into a circular ring. This ring is then expanded and roll-formed to achieve the correct profile. It must match the tire bead geometry and include safety humps to prevent tire slippage. Once formed, the rim is friction welded to the disc section in a high-energy rotary welding process that guarantees a strong, uniform bond. The welded wheel assemblies then undergo heat treatment to relieve residual stress and enhance structural strength. After cooling, the wheels are shot blasted to clean the surface and prepare it for finishing. A corrosion-resistant powder coating or E-coat is applied, followed by baking in an oven to ensure durability. Each wheel is subjected to strict quality control, including dimensional inspection for weld integrity and dynamic balancing to ensure smooth performance. Finally, wheels are laser-etched or stamped with traceability codes before being packed and shipped. Indeed, it's remarkable that even with all the high-tech automation, hydraulic presses, CNC machines, friction welders, and robotic coaters. The production of steel wheels still relies heavily on skilled human hands and sharp eyes. Operators manually inspect surface quality, verify weld integrity, and fine-tune machines during setup and maintenance. Human expertise is especially critical in quality control, where subtle imperfections or deviations can mean the difference between safety and failure. In a process where strength and reliability are paramount, the synergy of automation and craftsmanship ensures each wheel leaves the line ready for the demands of heavy-duty transport. At Toyota Turkey, the values of continuous improvement and respect for people drive every process. As one of the world's largest automotive manufacturers, Toyota brings its legacy and philosophy to Sakarya, where production began in 1994. With an ambitious export drive in the 2000s, Toyota Turkey has become one of the country's leading exporters, delivering vehicles to over 50 countries across Europe, North Africa, and Central Asia. The journey of each vehicle begins in the press shop, where large steel coils are cut and shaped into body panels. Using advanced dies and high-precision machinery, these parts are formed and inspected for surface quality before continuing down the line. In the welding shop, the body structure is assembled using high-automation spot welding lines. Structural accuracy and joint integrity are ensured through laser-based gap and surface inspections, crucial for both safety and comfort. At the paint shop, the goal goes beyond coloring. Each body is coated with protective layers to ensure corrosion resistance and acoustic insulation. UV-resistant, water-based paints are applied by robotic arms, meeting environmental standards while enhancing surface finish. In the assembly plant, around 3,000 components are fitted onto each vehicle. Intelligent systems verify each operation, preventing errors before they occur. After full assembly, every car undergoes detailed inspections for visual, mechanical, and functional quality, followed by dynamic testing on simulation benches that replicate real driving conditions. Toyota's philosophy ensures every stage treats the next as a customer, enabling a zero-defect culture. If any issue is detected, the production line stops automatically for immediate resolution. This system guarantees quality, safety, and consistency. All employees participate in daily warm-up exercises and are encouraged to contribute to continuous improvement through teamwork and innovation. With a strong commitment to sustainability, Toyota Turkey uses eco-friendly technologies, recycles 100% of its production waste, and works actively to reduce its carbon footprint. As it expands into new global markets, Toyota Turkey is on the path to becoming a model plant, where the future begins today. Andritz offers advanced workshop capabilities for screw press upgrades, combining innovation, precision, and sustainable practices. In a recent project, a customer's existing screw press was upgraded, using a mix of refurbished and newly manufactured components. The process began with the shipment of the original equipment to an Andritz workshop, where a full inspection and assessment were carried out. A newly modified screw flight, designed to optimize performance and material throughput, was installed, along with upgraded wear protection on the shaft to extend service life. Existing screen baskets were carefully refurbished, while additional new baskets were added to enhance efficiency. Other reusable components were thoroughly overhauled and restored to original specifications. Once all parts were prepared, the press was reassembled at the workshop by experienced technicians. Full functional checks and quality controls were conducted to ensure reliability and readiness for immediate operation. The upgraded unit was then packaged and shipped for installation at the mill site. This approach not only maximizes equipment lifespan, but also reduces lead times and total cost of ownership. Andritz's workshop services demonstrate their commitment to delivering high-performance, cost-effective upgrades tailored to customer needs. Watch as the Smith Services team performs the precise removal of a 45,000 lb rotor from a massive 32 megawatts industrial generator. With only 3/4 inch of radial clearance, technicians use a custom 20-foot steel tube, 1 thick and weighing 3,300 pounds, along with 2 synchronized 50-ton cranes to carefully float the 20-foot rotor out. This delicate operation showcases expert coordination, precision rigging, and specialized tooling, all crucial for servicing the 127,000 lb generator. It's a powerful demonstration of heavy industrial maintenance, where even the smallest misalignment can jeopardize the entire operation. Hot tapping a DN150 branch onto a pressurized DN250 ductile iron water pipeline is a delicate yet efficient method enabled by the TONIS-COB30 system. The operation begins with preparation of the stainless steel saddle, which is separated and thoroughly lubricated using TONISCO sealant oil. The bolt threads are greased with TONISCO paste for proper tightening and corrosion prevention. Once the halves are loosely joined around the pipe, the sealing plate is inserted and a gate valve is mounted on top. The flanges are bolted together, and all screws are tightened according to specification, starting with the lower saddle bolts to ensure proper alignment. Shaft extensions are added to the base to reach the tapping depth, and a hole saw with a pilot drill is mounted using a chuck. A small magnet is attached to the pilot stem to capture drill shavings. The sealing rings on the adapter body are checked, cleaned, and lubricated before assembly. The shaft is lubricated and inserted, and the adapter is connected to the valve flange. A pressure test is conducted using pressurized air and leak detection spray. Drilling begins with maximum RPM using an electric or pneumatic drive, increasing feed once the pilot drill centers. Feed wheel adjustments are made to lock each groove. Completion is verified by pushing the shaft forward. If it advances, the tap is done. The brake line is then secured, the valve is shut, and internal pressure is relieved through a control cock. Residual water is drained from the adapter, revealing the cut coupon inside the hole saw. The branch line is now ready, waiting for further installations. The hot tapping is performed successfully. This precise process enables live pipeline branching with zero service interruption. The pipe bending process using pressure rollers involves gradually shaping the pipe by applying force through rotating rollers. This cold forming technique ensures smooth, precise curves without compromising the structural integrity of the material. After the critical repair of the shearing cylinder, the team begins the meticulous reassembly of the Eticut 1240, an industrial-grade thermal cutting system known for its precision and robustness. Over 3 days, the machine is brought back to full working condition, with each step carefully executed to restore accuracy and reliability. First starts with the reinstallation of the repaired shearing cylinder into the cutting unit. Using lifting gear and alignment fixtures, the cylinder is positioned and bolted securely onto the machine frame. Hydraulic lines are reconnected, and pressure tests are carried out to ensure there are no leaks and that full stroke motion is smooth and responsive. With the cylinder mounted, technicians begin aligning the gantry system on the dual running rails, ensuring precise movement across the cutting table. Then is dedicated to the mechanical and electrical reintegration. The cutting head carriage, housing both plasma and oxyfuel torches, is reinstalled onto the gantry. Cable drag chains, sensor lines, and height control actuators are reconnected. The CNC control cabinet is powered up, and communication with the motion drives is confirmed. Technicians then calibrate the Z-axis, verifying that the torch height adjustment system works in coordination with the material surface tracking sensors. Final focuses on final system integration and functional testing. The fume extraction system is inspected, the cutting software is reloaded, and test sequences are initiated. The shearing cylinder is tested under load, confirming that it actuates cleanly at the end of each cutting path. Sample cuts are performed in varying thicknesses of steel, checking for clean edges, accurate geometry, and synchronized tool motion. By the end of the 3rd day, the Eticut 1240 is fully reassembled, recalibrated, and returned to operational status, ready to resume precision cutting tasks with restored mechanical integrity. At Tri-State Wire Rope, heavy-duty splicing is a critical operation, ensuring strength and safety in high-load applications. In this example, technicians splice a 1-1/2 diameter wire rope, a robust cable typically used in construction, lifting, and rigging operations. The process begins by carefully unlaying the strands at the rope's end. These strands are then intricately interwoven into the main body of the rope using the hand splice method, a traditional yet highly reliable technique. Precise strand positioning is essential to maintain load integrity and prevent weakening at the splice point. Each tuck is manually executed and compacted to ensure even distribution of tension. The work demands experience and strength, especially with such a thick cable. Once the splicing is complete, the rope undergoes a thorough inspection, checking for uniformity, tightness, and alignment. For high-capacity applications, spliced eyes or terminations are often reinforced with steel thimbles to reduce abrasion and maintain the rope's shape under load. In many cases, the finished splice is subjected to pull testing to certify its holding strength according to industry standards. Tri-State Wire Rope specializes in custom wire rope fabrication, offering solutions for bridge construction, industrial hoisting, marine applications, and more. Their splicing process combines skilled craftsmanship with rigorous quality assurance, delivering safe, dependable results for mission-critical operations where failure is not an option. The High-Speed Rail (HSR) project is a fully integrated electric railway network stretching 1,750 kilometers across Egypt, with trains reaching speeds of up to 250 kilometers per hour. Designed to transport passengers, tourists, and cargo, it connects the country's eastern and northern coasts with Luxor and Aswan. The project also aims to link Egypt with neighboring countries. Siemens, in partnership with Egyptian construction firms, is leading the implementation. EDEX is responsible for constructing the station, overpass, at the Cairo-Fayoum junction and the track leading to the Hidayek October station,